I'm in the workshop and it's time to do a project. We've got an Irvine XR15 engine here that I bought probably 2 years ago. Got two of them, and I've also got an Irvine 15R Turbo, which is the previous model of this that I previously converted for Goodyear Team Race. And now it's time for this one to have a go at Goodyear Team Race. This is being a later model, slightly more advanced in some of its internal arrangements, so it should be an even better engine. As you can see, it has the big blue head on it because it is a car engine. It is intended for radio control cars, and it will take some work to get it to be suitable for slow Goodyear Team Race. And as an example, I have right next to it my slow Goodyear Team Race model. It's won a couple of national championships and won a lot of races, done very well, and it is equipped with a Nova Rossi Rex CR12F, which is also based on a car engine, but converted at Nova Rossi for control line or free flight use. These were available quite cheaply a few years ago, so I got this one for $105 US, a total bargain, and it has been a fantastic engine. It's so beautifully made, extremely good at hot starts, and even though it's only a 2.2cc, fast enough to do the job in 2.5cc Goodyear racing. So the only modifications this engine has had is that the venturi is 4.5mm instead of 4mm, just to give it a little bit more power. And you may be able to see that I chopped the end off the glow plug so that the hot thumb glow connection fits a little bit more nicely. So that's something that we will attend to on converting the Irvine to fit. So as you can see, there is no venturi in there. There's a plastic shim from where it used to have a throttle fitted. So that is the primary task at hand. And one of the things that I've observed is that when you put it in position, the hole there for the well, potentially the needle valve, but where the throttle is attached, is not quite in the same plane as the Nova Rossi needle valve, and that's a factor that determines how you set the engine to run on the ground when you're starting it and warming up and taking off versus how it runs in the air. It needs to be, let's see if we can illustrate that. You can see that there is probably about 5 to 7mm between the pickup point where the fuel is picked up in the fuel tank and the plane of the needle valve relative to the handle. So that needs to be about there in order to get the best balance of on the ground setting versus in the air setting, so that when you take off the engine runs rich and isn't prone to leaning out and sagging. So that is going to be one of my primary considerations. Now, the Irvine being a 2.5cc engine, it'll have a bit more torque than the 2.2cc engine, so that needle valve hole there should only need to be 4mm, so we'll start with 4mm. See where we get on, and the idea is to swing an APC 7x4 prop at, let's say, 18,000 RPM, and if it can do that in the air, it should be pretty close to, or a bit more than that. If it can do that on the ground, it's doing well. If it can do that in the air, 20,000 in the air, should be pretty close to the speed limit of 26 seconds for 10 laps, which off the top of my head is around about 130 something kilometers an hour. So that's the thing with slow Goodyear, speed limit. Very few other restrictions, but you don't go faster than 26 for 10. So just looking at the Irvine, as you can see, the big blue head is going to have to get trimmed down. It's a standard glow plug, which is fine for this application. We will want to get probably down to the first two fins, maybe the third one, and that would suit having the tip of the glow plug there in the right place so that the hot thumb connection can go on there without being misaligned. And we'll trim the diameter down so it's the same as this. These fins here. The prop drive is okay, but it's slightly big, so we'll trim that down a bit too to make it fit the small diameter of the APC prop. And we'll make a venturi to go in there, 4mm venturi, well the equivalent of a 4mm venturi, because we're going to use the Enya 4mm diameter spray bar through the middle, and that calculates out to a 7.1mm diameter hole to give the equivalent of a 4mm straight through venturi. So let's start by, we'll take the needle valve out of its packet so we can get a look at it. Conventional Super Tiger style needle, but made by Enya in Japan to a very high standard, which we like. So I'll take the needle out. So pretty conventional. I don't know if you can see it close up, but probably a little bit more pointy than ideal. But for slow Goodyear running on suction, that's going to be really good. There's the gland, normal split gland, and tapered gland nut that tightens it up. So basically ideal for the application. Next, we'll take the head off. 6, I think they're M2.5 screws. Nice close fit. Fairly conventional head, tapered squish, and hemispherical bowl. The glow plug sits pretty much flush with the bottom, so whatever glow plug that is, it's quite a good size, whether it's medium or long, or indeed short reach. One shim, copper, 0.15mm. That's an unusual size, but it'll work. We'll measure the clearance at some point as well after we've machined it. Aluminium piston, chromed brass liner. Piston material on these is reputed to be quite good. The Marley alloy from Germany. Now, one of the things I can see looking in here is that these ports are much bigger than they are on the 15R turbo, which bodes well. And we'll measure the exhaust timing and things like that, just so that we know what we were looking at. But for the time being, that's not our main priority. It's, I think the port height is something like 4.2mm, and that's right about what we're looking for. It's a plastic bush to heat insulate between the crankcase and the throttle, so that the heat of the crankcase doesn't affect the throttle settings. Now, normally on a control line engine you wouldn't bother with that, but one of the things we need to do is to get the needle valve position slightly outboard, so about there, which we can do by putting it in the venturi. That means that we can have heat insulation between the spray bar and the crankcase, and that helps us if you're getting a hot engine coming in to a pit stop and you put fresh fuel in it. The heat of the crankcase can boil the fuel and prevent fuel from getting through on the hot start. It's not usually a problem, but it is potentially a problem. If we can eliminate that problem, then that's good. We can do that for free because we've already got this here. Last part, we'll just get the back plate off and have a look and see what it looks like inside there. There we go, conventional machined aluminium backplate with an O-ring seal, which is really good. We have counterbalanced crank web. We have a bushed rod. It appears to be a machined rod, not forged, so that's good. And can't really see much about that piston, but it looks like a machined piston. That's also good. And may be able to measure that hole. 6.89 millimeters, probably close to 7 in reality. There we go, 7 millimeter hole, that's fine. With slow Goodyear, you're not looking for maximum peak performance, you're looking for extremely reliable mid-range performance. But extreme reliability and consistency is the key, because you want very good hot starts, and you want it to be running comfortably so that it doesn't overheat in overtaking, and it doesn't overheat when being held back, because during a race with speed limits, holding back, being held back, and not slowing down on overtakes is how you win. You want to be running close to the limit all the time. So it's best if your engine is not running close to the limit. It's running comfortably. So there we go, that's the basics of it. The engine itself looks really, really good. This has never been run, so obviously it's good in that respect, but in terms of the design of it and the way it's set up, it looks ideal for our needs. So next task is to start modifying the parts to suit our needs. Next task at hand, modifying the prop driver. We'll put the collet onto the mandrel. The mandrel is a 7mm mandrel that I use for doing spinners. There's the standard Irvine prop driver. Bump that on there, and we'll just turn down the first diameter to probably about 17mm. You can see from a broken slow Goodyear propeller how much bigger it is, so it's nice if that's much similar. Alright, next order of business is to bring this head down to a more reasonable diameter and height. The fins on the rest of the engine are 33mm in diameter, which is perfectly reasonable for a car engine, probably a little bit excessive for aero use, where weight is more of a factor. But 33 is fine. I might go 32 just to knock a tiny bit of weight off it. But yeah, a good diameter first, and then we'll flip it over and cut the top off. So that's the diameter, it's down to 33. I'll leave it as it is because that blue stripe looks nice. And if I take it to 32, the blue stripe will disappear. is. Time to do the Venturi. This is 2007 free machining aluminium, and that will do very nicely. Do a 16mm diameter, and we'll do a 7.1mm hole, or the imperial equivalent, and a spigot. The spigot needs to be 11mm diameter so that it's a tight fit. Okay, we're back on the bench. The lathe work is done. We have modified head, modified prop driver, brand new Venturi, and the other parts. So let's put it back together. Easy part first. There is no up. It goes the same. Sometimes I'll have a notch in there, which is always going to be up, but not this time. Shiny new cylinder head. We'll put the same shim back on and measure the clearance and see how it comes out. Let's wipe off any muck. Prop driver collet. Prop driver has been turned down a little bit to make it match the propeller. That's a broken one, but as you can see, that's a bit nicer fit than it was before. Would be nice to have a nice spinner nut on there, but I'm not going to bother. I'll find a bigger washer though. So that would be on there. That'll work with a better washer. And now the important part, the Venturi. So that is 7.1. I should measure it, but I think it's 7.1. Let's measure it. I need a ball gauge to measure it properly, but yeah, 7.1. Which, with a 4mm diameter spray bar, equates to a 4mm diameter hole in terms of area, which is about what we want to start with. We'll find out. Time will tell. Testing will tell what is actually needed. But with a spray bar right through the middle, the surface area is the same as a 4mm hole. You can see the spray bar hole is bang in the middle, and you nicely put a little indentation on the hex to tell you when it's pointing directly downwards. So when the indentation is up, the hole is down. Perfect. Put the nut on. The nut only goes one way. I won't do everything up because I still have to do the mounting holes. So that'll go on there. So what I'm going to do is tilt the spray bar slightly backwards. Not too far backwards because we still need to have the fuel tube coming off here without hitting the propeller. But this keeps the needle valve a little bit more out of the way. We'll shorten the needle valve too, but when you are starting, hitting it hard, hitting the needle valve is a potential problem. So having it angled back reduces the chance of your finger hitting the spray bar in the heat of battle. So far so good. So next we will take off the spray bar and mark those holes. So an angle that keeps the fuel tube out of the way is important. I think that's probably as much as we can do. About that much, not that different to a PA dub. Okay, that's gone. So now we need to mark those holes. That hole is 1/8 of an inch. Right. Now drill and tap those to M3. Alright, we're back. Mounting holes drilled and tapped in the Venturi. I'll put this on first so that I can make sure it's aligned. Alright, now it's a tight fit in the plastic bush. The plastic bush gives us our sealing against the crankcase, so we don't need an O-ring. Push it in as far as it'll go. M3 screws, but button head screws, so they use the same Allen key as the head screws. How convenient. Probably a good idea to Loctite these in ultimately, just to make sure they don't fall out. Most of the manufacturers who use those kind of fittings will Loctite them in. Now I will find a decent propeller. So here is a decent propeller, APC 7x4, the ideal propeller for glow engines in slow Goodyear. Nice full diameter, lots of momentum for starting, low pitch, gives you good acceleration out of the pits, and keeps the engine from being loaded up too much or going too fast. And you don't have to modify them. A very, very high quality propeller. So now we'll put the gland nut on. That adjusts the tension of the needle valve. So as you can see, that sticks out quite a far way. It's too long, so we will have to shorten that significantly at some point. Adjust the tension with the gland nut. It needs to be quite tight so as not to change during flight, but loose enough that you can move it if you need to. That's alright. So yeah, there's a lot of needle valve sticking out, and we'll have to bend that over a lot shorter. There we go. Irvine 15 XR, or rather XR15, converted for slow Goodyear Team Racing. There we go. It's all done. Ready to test. Reshaped, resized head. Tailor glow plug is back in there. APC 7x4 prop. Prop driver is trimmed down to match the prop. A new Venturi 7.1mm diameter, which gives us the equivalent area of a 4mm Venturi. In-ear spray bar and needle valve. The needle valve has been trimmed down and reshaped to make it look a little nicer and keep it out of the way. So at some point soon we'll give it a test run.